In this video, we're going to learn to write the rule or the formula to find the nth term of a geometric sequence when given the value of several of the terms. I want to do a quick disclaimer that my method for writing this formula is going to be different than the method you're going to see in a lot of other videos. And the reason I'm doing that is I want to see the connection between geometric sequences and exponential functions, okay? A lot of books would have you learn one rule for writing these and one rule for writing these, but I think it's important that we see the connection between the two. So I'm going to have us write geometric sequences in the form that most people write exponential functions. So once again, if you're a student of some other teacher, you may not want to watch this video because this might be different than what your teacher's looking for. This is specifically for my students. Now let's start with an example. Here we've got a sequence, and in this sequence, I've written it as a table. But what we should know and remember about sequences is this n value is the term number. That's like our independent variable. And then the actual term value is f of n. That's like our dependent variable or our y. So if I wrote this as a sequence, it would be 6, 12, 24, 48, so on and so forth, okay? And what we're doing is we're going to write the formula to find the nth term in the sequence. In other words, if I gave you the sequence and I said, what's the 20th term in the sequence, we could just substitute 20 into our formula and find the answer. So let's kind of fill in our little table here, because I think this table is going to lend some insight into how to write that rule. So I'm going to fill in. We know that our first term is 6, and our second term is 12, our third term is 24, and our fourth term is 48. Now, here's where I do this differently than some textbooks. I want us to backtrack, and I want us to find what would be this value right here. What would be this number before the first term, which doesn't really make sense when you're talking about a sequence, but if you were talking about an exponential function, that would be our y-intercept. So in order to backtrack and figure out what goes right there, we need to see the pattern that's going on in our table. And if I'm looking at my table, it looks like we have a geometric sequence with a common ratio of 2. That means we are multiplying by 2 each time to get to the next value in our table. So I know that there, some number times 2 would give me 6. Well, just by eyeballing it, I can tell that that number would be a 3. You could also do 6 divided by 2 to get that 3. But now we're here, okay? And we see that this would be that value before the first term. If we were curious, there would be like a 3 right there before the first term. But considering our sequence that we have, now that we've got this filled into our table, let's look at this process column, because this is going to help us understand our formula for writing the sequence. So it looks like I start with a 3. And then to get to the 6, I do that 3 times 2, because that common ratio, I can do that in the same color even, that would give us the 6. And then to find the next term, we take the term before it, which is 3 times 2, and then we multiply it by 2 again. So we start with a 3 and we multiply by 2 twice to get 12. And then to find that third term, that 24, we can take the value before it. So what I have shown here represents 12. And then we're going to multiply it by 2 one more time. And then you can probably see the pattern. If I keep multiplying by 2, in this case 4 times, that would give us a 48. So let's write our rule down here to find f of n, or the nth term in the sequence. So it looks like no matter what, our rule is going to start with 3. And then it looks like after that we're multiplying by a certain number of 2's. To find the first term, we multiply by 2 one time. To find the second term, we multiply by 2 twice. To find the third term, we multiply by 2 3 times. And to find the fourth term, we multiply by 2 4 times. So to find the nth term, the way we could rewrite these is I could rewrite it with an exponent. Repeated multiplication can be written with an exponent. In other words, 2 times itself 2 times the same thing as 2 squared. 2 times itself 3 times the same thing as 2 to the third. And 2 times itself 4 times the same thing as 2 to the fourth. Therefore, 2 times itself n times would be 2 to the n. So therefore, our rule or our function is going to be 3 times 2 to the n in this case. And we remember what these mean. This 3 is kind of like our value before that first term. Remember how we kind of backtrack to find what would that value be right here if there was such thing as a value, okay? And then this number right here, that is our common ratio. When we go into exponential functions in a few lessons, we're going to call these by different things. Like, for example, that 3 is just going to be our y-intercept. And that common ratio, we call that a growth rate when we deal with exponential functions. But basically, this is the stuff that I was hoping we derived on this slide. And just to kind of hammer it home, we see on the last slide that for this same sequence, we had that f of n, the nth term, would be that 3, that value before the first term, times our growth rate to the nth power. So if you wanted to just generalize it, you could say a times b to the n, where a is, once again, that value before the first term, and then that b value is our, oops, I almost called it a growth rate. I'm thinking exponential functions. And that b value is our common ratio. Okay? Now, let's do a practice. Write the explicit rule for the sequence shown in the table. Well, I can see, first off, that if, actually, let me write my general form. F of n equals a times b to the n, and we know that this is going to be our common ratio, and we know that this is going to be the value before the first term, okay? Now in this case, let's start by finding our common ratio. I see a pattern in how we're progressing. It looks like we're multiplying by 3 every time. Therefore, over here, my common ratio is going to be A3. Then we just have to find our A value, which is this value before the first term. So some number times 3 gives us a 1. So if you can't eyeball it and just tell what that is, what you can do is I can just go the other way, and the other way would be 1 divided by 3, which in this case is 1/3. So this is your explicit rule for this sequence. If I want to find the 20th term in this sequence, I just put in a 20 for n and work it out. If I wanted to find the 50th term in this sequence, I would just put in a 50 and work it out, although that's going to be a huge number. But there's that one. Now, we got 3 practice problems. So what you might want to do at this point is you may just want to pause the video and try these out on your own and see if you get them, and then hit play whenever you're ready to check your work. But I'm going to go ahead and get started. I can see on the first one that our common ratio is a 3, and that value before the first term, if there was an invisible value right there, it'd be whatever 2 divided by 3 is, and 2 divided by 3 would be 2/3, so that's like that initial value, the value before the first term, times my growth rate to the nth power. So that's your answer to number 1. On number 2, I can see my growth rate is, it looks like a times 4. And then if I had to figure out that value before the first term, I could just do, if I couldn't figure out what number times 4 gives me 5, I could just go the other way and do 5 divided by 4. And 5 divided by 4, that initial value, I could just write it as a fraction as 5/4. As a decimal, that would be 1.25. And we're doing that value times my common ratio to the nth power. And then lastly, let's come down to this last one. If I look at my growth rate, now it's interesting here because our terms are decreasing. They're getting closer to 0. So 10 times what gives me 5? Well, if I wasn't sure, I could just do 5 divided by 10, and that looks like a 1/2. Okay, so it looks like my growth rate is a 1/2 here. Each time I'm multiplying by half to find the next term. Okay, and so that means some number times 0.5 some number, when I take half of it, gives me a 10. That means that value before the first term here is a 20. So for this last problem, my initial value, that value before the first term, would be a 20, and then my growth rate would be a 0.5, or I can write it as a fraction, to the nth power. So here's your answer to these three questions, 1, 2, and 3. By the end of this video, you should be able to take a sequence, whether it's given in a table or written as an actual sequence, and write the rule for it.